Problem of the day number 17. So this is going to be the last proof that we do in terms of congruent triangles, at least for now. And we're again extending that triangle proof into once you get that, what happens after that. And also this proof does not give you how many steps there are. So you use as many steps as you need to prove the thing that you want to prove. Okay, so this is saying that we have a center with this, we have a circle with a center at O. So that, remember, usually when they give you a circle with a center somewhere, we want to look for radii. Okay, so in this particular case, because O is the center of the circle, then we know that OB, that's going to be a radius, and OC is also going to be a radius. So we have two radii, and because all radii of a circle are congruent, they're also going to be congruent to each other. Okay, and we also have that OD is perpendicular to BC. And so what does perpendicular really mean? It means that you end up with right angles. So we know that angle ODC is a right angle, and we also know that angle ODB is also going to be a right angle. And because they're both right angles, that means that they're going to be congruent because all right angles are congruent. So now that we have those, then we can also see from the picture that because these two triangles are sharing that side OD, that side is also going to be congruent. So we can prove that these two triangles are congruent by hypotenuse leg because they're right triangles, right? So this is the hypotenuse of that triangle and this is the leg of the triangle. So then those two triangles are going to be congruent by hypotenuse leg. Then from there, let's look at how we're going to get to this conclusion. So OD bisects angle BOC. So angle BOC is this large angle here, and we want to prove that OD is bisecting that, so cutting it in half. Now, how would we be able to get that conclusion? Well, it'd only be if we know that these two angles are congruent first. So if we know that those two angles are congruent, then we can show that OD is actually bisecting the big angle. And the only way to get those two angles to be congruent is to prove that the two triangles are congruent. And then we can use CPCTC, or it could use two congruent triangles implies two congruent angles. Okay, so that's going to be our game plan. So now let's write down each step. So number one, we know that we have a circle with the center at O. And because circles and zeros and O's all look so similar, for a circle, I tend to draw a circle and put a dot in the middle to show that I mean the shape of circle. And then when I have to write O, I usually use a cursive to differentiate between a zero, for example, right? But as long as you can make a way to differentiate between them, then that's fine. Okay, so because we have a circle with the center at O, that means that we have radii, right? So we know that BO is going to be congruent to OC, okay? Because all radii in a circle are congruent. All radii of a circle are congruent, okay? Number three, so we're gonna mark that, okay. And that's all we can get from that circle. So now let's go on to the next given, that OD is perpendicular to BC. So OD is perpendicular to BC. Again, I'm not gonna worry too much about whether it's a line or a segment, because in this particular case, all we care about is that they're perpendicular. It doesn't matter if they're gonna go on forever or if they're just gonna stop at their endpoints. Okay, so this is given. And so because we know that they are perpendicular, that means that angle ODB is a right angle. And we know that also angle ODC is also a right angle, And the reason for that is perpendicular lines form or imply right angles. Okay, so that means that in part 5, we know that they're going to be congruent because they're both right angles. Now we can't just take that for granted. We actually still need to write it out. We need to, actually write that as a step. So angle ODB is congruent to angle ODC because all right angles are congruent. Angles are congruent. Okay, so we have that this angle and this angle are congruent. Oh, let me label the thing. So that means that it's a right triangle. Oh, maybe that's what we need to do instead, actually. Instead of writing that they're right angles, and they're congruent, because for hypotenuse leg, we don't actually need that the angles are congruent. We just need that the triangles are right triangles. Okay, so actually I'm going to go back and maybe erase this, because we don't actually care that the right angles are congruent. That's not necessary for hypotenuse leg. So that means that triangle ODB is a right triangle, and triangle ODC is also a right triangle. Is a right triangle. Okay, so right angle implies a right triangle. Depending on your book or your teacher, you might not even need to write that. If you just have that they're right angles, then that automatically implies that they're right triangles. So that one is probably also another reason why they don't have a set number of steps, because some books or some teachers might require that step and some might not. Okay, so now that we know that those are right triangles, again, we've run out of givens. So there's nothing else to get from the givens. So now we look at the picture and see what else we can get from that. So we can see that in this picture, they overlap on that side right there, that OD. So we know that OD is congruent to OD by the reflexive property, because we're putting the same thing in that we're getting out. And so that tells us that, so OD and OD are both legs of a right triangle. And now that we know that they're right triangles and the radii are congruent, these are the hypotenuses of the right triangle. So we know that these two triangles are congruent by hypotenuse leg. Okay, so which triangles are they? Again, it doesn't matter what order you choose for the first triangle, just pick an order. So for example, ODB, okay, is congruent to triangle. So we went from the one mark to the right angle and then to the unmarked vertex. Okay, so in the other triangle, do the same thing. Go from the one marked side to the right angle. So that's O to D, and then to the unmarked vertex, which would be C. Okay, so those two triangles are congruent. And now that the two triangles are congruent, remember, we're trying to get to the point that we know that OD is bisecting the angle BOC. And the only way to get there is to prove that the two angles are congruent. So we have that this angle is congruent to this angle here. So for step 8, we have angle DOB is congruent to angle DOC. You can also write angle COD there. It really doesn't matter. Okay, and the reason for that is CPCTC, corresponding parts of congruent triangles are congruent. Or you might just write congruent triangles. Congruent triangles implies two congruent angles. Okay. And because we know that the two angles are congruent now, then we can conclude that OD bisects angle BOC. Okay, and the reason for that is two congruent angles implies angle bisector. Or some books might write reverse definition of angle bisector. Okay, depending on the book that you're using.